Astronomers now believe that a mysterious dark energy makes up 70% of the composition of our universe, while dark matter makes up another 25%. Robert Kirshner, Clues Professor of Science at Harvard University, is an astronomer at the Harvard-Smithsonian Center for Astrophysics. Evidence that his team gathered has revealed that our universe is expanding at an ever-increasing rate.
Well, I'm an observational astronomer. I make measurements of things, usually using telescopes. I do pretty much what you think an astronomer does do. I go to a telescope and make measurements of things. In this case, it's exploding stars, and the purpose of those measurements is to find out the history of how the universe has been expanding. I got interested in astronomy pretty early. There was a neighbor who had a telescope, and he was kind of having trouble setting it up, and I thought, oh, how hard can this be? And, so we figured out which way the North Star was and got the axles pointed the right way. But I do remember just being impressed with, the mystery of it, sort of the visual experience, too. Well, we've gotten a really big surprise, which is that the universe seems to be expanding outward faster over time, not slowing down the way we expected. And so we think there must be something that has this kind of anti-gravity quality to it, which we call the dark energy. So finding out what is making the universe expand is something which is actually within our grasp. And the technique for doing it that I've been working on is to use these exploding stars, the supernovae, to try to measure the history of cosmic expansion. It turns out that a certain kind of supernova is pretty much the same from one galaxy to the next. They have the same brightness. So that means we can judge their distance from their apparent brightness. Now, that's one part of the story. How far away are they? The other part is really how fast is the universe expanding. So that we have dark matter on one hand, which is gravitating stuff that's slowing down the expansion of the universe, and dark energy on the other. And the funny thing is that ordinary matter, the stuff we're made of, seems to be just almost unimportant in this picture, that we're just the frosting on the cake. The real cake is made of dark matter and dark energy. There's a kind of tug of war between these two things, that the dark matter's trying to slow things down. It has ordinary gravity of the kind you would think stuff ought to. Whereas the dark energy has the opposite effect of making things speed up, of making the expansion go faster over time. We've given them these sort of flippant names. The curious thing is we don't know what either one of them is. We do not know what the dark matter is really made of. There's been no laboratory measurement of the dark matter. And we don't know what the dark energy is either. We know what it does. We know that it makes things speed up. We measure that from looking at distant supernovae, and they seem to be a little farther away than you would expect, which means that during the time that the light was coming from the explosion to you, the universe expanded a little extra. And this extra expansion, this speeding up of cosmic expansion, is what we attribute to the properties of the dark energy. The thing that makes me think that we're not on the wrong track and that this really is real is not just that we've been measuring the supernovae better and better over time or getting more and more of them, but that there are other directions of approach to the problem. So people have been looking at how galaxies cluster from big galaxy surveys, and that turns out to tell you something about how the dark matter and the dark energy have been competing over time. I think in the long run, we'll understand more about what happened in the Big Bang, not less, and that there's no kind of barrier that says, beyond here, human beings will never understand anything. So I think that we're doing okay with our limited little brains. We're getting these little clues of starlight, and we're puzzling out what they mean. We've got this picture of an expanding universe. We're able to build instruments to see way back in the past. We're putting all that stuff together to make a picture of a universe which is very surprising, starting in a Big Bang 14 billion years ago, accelerating now, full of this darkness, this dark energy and the dark matter. But, and even though we don't understand what those things are today, it doesn't mean we won't understand, 10 or 20 or 30 or 50 years from now. We may understand very well what those things are, and we'll be on to understanding a kind of new level of mystery about the universe.